All right, hello, my wonderful students. This is the foldable number 2 of section 6.4, converting between exponential and radical functions. I believe this one also has, yep. So we're going to go ahead and get started with the first one here, or the first set has 4 that we're going to work on. This one, once again, is working on the nth root of x to the n power is equal to x to the n over m over n, or you can switch these vice versa. These also have a thing, so the first two we're going to be writing in radical form. Okay, it's relatively easy for this one. Let's go ahead and do our blue. We're just going to kind of plug in what these are. We have x to the 3/7. So if we put this here, our 3 is going to be equal to our m, and then our 7 is going to be equal to our n. So now we can go ahead and set up our radical, and we put our base inside, and our nth root was 7, and our power was 3. Simple, nice and easy. Okay, we're going to go ahead and go to our z. We're going to use the same method for this one. So we have our, there we go. We have our m is going to be equal to 2, and then our n is going to be equal to our 3. So we can go ahead and write a radical, put our z inside, and we can see that our m is going to be our power, which is our 2, and our n is going to be our root or our index, which is going to be our 3 there. So this is going to be the cube root of z squared. All right, for this next one is going to be a little bit different. So for this one, I'm going to do in green. We have y to the negative 3.5. Whenever we're doing expressions or exponential values of a 0.5 nature, what we're going to do is we're going to change this this from 3.5, we'll forget the negative for now, over 1, and we're going to multiply the top and the bottom by 2 to get rid of the 0.5, and that's all we're really doing. So this is going to equal 7 over 2. So instead of having our y to the negative 3.5, we're going to have y to the negative 7 over 2. Because this is a little bit easier to work at than a 0.5. Okay? So that being said, now we have our m is equal to 7 and our n is equal to 2. But before we actually go ahead and do that, what we're going to do is we're actually going to rewrite this as our because we have a negative exponential value. Remember, when we have a negative exponential value, we can actually change it to 1 over y to the 7 over 2 power to make it a positive exponential function, because we're not actually allowed to have negative exponentials. So now we can go ahead and change it to this form here. We have our m and n already labeled, so we'll go ahead and make this equal to 1 over, that kind of scared me a little bit, the radical, and it's nth root of square. So we could write a 2 here if we wanted to, but the square root is kind of, it's just a symbol itself, the radical of what would be inside, because we don't, since it's the most common use, we don't actually write the 2 there. So this would be y to the 7th power. And now this is just basically what we did last section. We're just going to separate this into different methods until we see how many we actually need or what's left. So we have this here, and this is going to equal our 1 over the square root of y to the 2nd times y to the 2nd times y to the 2nd. And we have 1 left over y. So we have 2, 4, 6, and then the 1 left over y here, which gives us 7. So this is going to come out, and it's going to equal 1 over 1, 2, 3y. So it's going to be y times y times y to the radical y. So y times y times y is going to give us, of course, our y cubed, radical y. And yes, I know you're saying, yeah, we're done. But we don't, because now we need to rationalize our denominator. So this is a square root of y, so we only have 1 copy, so we need 1 more copy in order for it to be able to be taken out. So we're going to multiply by that 1 more copy that we need, and we're also going to multiply the top by that 1 more copy. So this is actually multiplying by 1. So we're going to go equals, And now we're going to have our 1 times square root y is square root y. And we're going to have our y cubed here. And it's going to be square root y times square root y would be our square root y squared. These will simplify, leaving us with an extra y to come out. So on the bottom, we're actually going to have our square root y over y to the 4th power. All right. On the last one over here, we have, we'll do in blue, we have a to the 1.5. But once again, same thing that we did over there, we're actually going to do that over here. We have our 1.5. We're going to put it over 1, and we're going to multiply this by 2 over 2. And this is going to equal 3 over 2. So we're going to change this a to the 3 over 2. Luckily for us on this one, we do not have a negative in the exponential function, or the exponential value. So now we're just going to go ahead and assign our m and our n. So our m and our n. So our m is equal to the top, which is our 3, and the n is equal to the root, or the index, which is our 2. So we can go ahead and rewrite this again, or now as our radical. It's going to be the square root of a cubed. Now we can go ahead and rewrite this as we know we have to get pairs, right? But we have 3 here, so we can rewrite this as a squared times a. The a squared would be able to reduce out, but the a will not. So this is going to just be equal to our, well, we can rewrite it as well. So I show you that extra step. We have our a squared, that's everything that comes out, and then our a does not come out. These will simplify out and leaving us just with our a, and then our radical a that does not come out.